Strings are objects. And so strings have attributes. The string hello has a method called upper, which makes it uppercase. That's part of the behavior of being a string. You can lowercase it. You can even swap case it. Now, none of these things have changed S. S is still hello. Each of these method invocations has returned a new string based on the old string. But it does something very string-like. So these aren't general functions. These are things that are just particular to strings, and that's why they're methods, as opposed to functions that are built into the language. Now, strings are an abstraction that allows us to represent text. But there is an encoding of those strings as numbers. And actually, this encoding is not specific to Python. It's shared among many programming languages. So I'll just tell you a little bit about it for fun. An original encoding, not the first one ever invented, but one of the first standards to take hold in computing, was called ASCII, the American Standard Code for Information Interchange. This was a table that laid out which numbers corresponded to which letters and symbols. There are 8 rows, and 8 is important because that's how many different rows you can represent using 3 bits, 3 ones and zeros. And there are 16 columns, which you can represent using 4 bits. The layout was chosen to support sorting by character code. So if you've ever used a computer and found that it sorts capital letters before lowercase letters, and puts things with an exclamation mark at the top and things with a tilde at the end, that's because of the order in the ASCII code chart. It was also designed so that if you didn't have enough bits to represent the entire table, there would be a useful subset right there in the middle. It meant you had to type in all caps, but that's better than nothing. The control characters at the top, here in red, were designed for transmission or information interchange. So they have original meanings, most of which aren't used today, but some of them still are. So the line feed, called LF, was supposed to tell the printer on the other end to go to the next line. And if you wanted to get somebody's attention after some information interchange, you might ring the bell on their printer. And these things still exist today. So if I say A is the capital letter A, I can figure out what number corresponds to that A. It's number 65, which in hexadecimal format is 41. 41 tells me the row and column of the capital letter A in my ASCII table. Oh, there it is, row 4, column 1. If I print the line feed character many times, I'll get multiple lines. And if I print the bell character many times, I should get a sound coming out of my computer. Now there are more characters than just these. The ASCII standard was English specific, but the Unicode standard was designed in order to have one character set that would be used for all different languages. So it's the case that for every character, in every language, in every script that's being used anywhere in the world, there's meant to be a Unicode code point for it, or a number ascribed to it, that lets us refer to that character as a number and use that for any kind of information interchange among computers, among different programming languages, etc. There are currently 109,000 characters, at least last time I checked, in 93 different scripts. And they're organized by script. So it's more than just enumerating all of the different symbols that people use in language. They're also marked with what's capitalized, what's not capitalized, what language they're used in, etc. And it even supports bidirectional display order. English is written left to right, but Arabic is written right to left. And every character has a name. The letter X is called Latin capital letter X. Now there are a lot of different characters, 109,000 of them, including a smiling face and a frowning face, which are just letters in some alphabet. And most programming languages support Unicode, and so you can access these characters directly. So I'll type from Unicode data, import name, and lookup. Name gives you the name of a Unicode character. That's Latin capital letter A. And that's a Latin small letter A. Lookup does the opposite. I start with the name, and it gives me the character. So if I look up the smiling face, there's that smiling face. We can make it even bigger so you can see just how smiley it is. And there are many more characters that are a little bit quirky. There's a snowman. There's a soccer ball. There's even a baby. Hello, baby. Now, depending on the font on your computer, these will be displayed in different ways. So I think only on the Mac do you see a baby that looks in this particular way with this haircut. But it could exist on other operating systems as well. The point is, there's a character representing baby. How exactly it's displayed might vary from machine to machine. But the idea that there is a baby out there with a particular encoding is universal to lots of different programming languages. And you can look at that encoding by encoding it in bytes. And you see these are the 4 bytes that it takes to represent a baby. Whereas the letter A is encoded just as the letter A.